Passport to Advanced Math Lesson 9 is all about exponential functions. These addressed standards 1 and 12. So let's look at what an exponential function is. Okay, first, an exponential function is a function in the form f of x equals a times b to the x, in which the variable expression occurs as the exponent. So what you have to understand is a and b will be replaced with numbers, and x will be your input value will be your exponent there. One thing I want you to know, a in the formula is always going to be your initial amount. What are you starting with? B is your rate of growth. And before we start talking about this, I'm going to say anytime we deal with percents, we always have to know to convert them to decimals. Very important to understand. So first, we have exponential growth. This is in the form y equals a times b to the x, where your b value is greater than 1. A lot of times in these problems, they'll give you the rate as a percent. So we would write our exponential growth function, right, as 1 plus the rate if it's increasing. Now, graphically, what happens is if it's growth, you start low on the left, and then it grows real quickly, right? And that's what your graph would look like. Again, anytime we're given a percent or a rate, we must change it to a decimal. And the easiest way to do that is to take the percent and divide it by 100, or move the decimal 2 places to the left. Okay, so if I had something like 3%, right, that would be equivalent to 0.03. 12% would be equivalent to 0.12. Now, if you have exponential decay, same form, y equals a times b to the x, but now your b value is greater than 0, but less than 1. And when this happens, if we're given a rate, we do 1 minus our rate, which is a percent that we convert to a decimal. Okay? So when we look at this graphically, on the left, it starts high, but then it decreases real quickly. So the first example here, Keith modeled the growth over several hundred years of a tree population by estimating the number of trees, pollen grains per square centimeter that were deposited each year within a layer of a lake sediment. He estimated there were 310 pollen grains per square centimeter. The first year, the grains were deposited with a 1% increase in the number of grains per square centimeter thereafter. Which of the following function models P of t, the number of pollen grains per square centimeter, t years after the first year of grains were deposited? Well, here's the thing. What was your initial amount? Your initial amount, A, was 310. Since it's increasing 1%, you know you're going to do 1 plus the rate, which is going to be 1 plus 1% is 0.01. And when you add these together, you get 1.01. So now your B value is 1.01. So when we write our function, P of t, that's going to equal our initial amount, 310, times 1.01 to the t power, which ends up being letter D. All right. Just knowing the format of an exponential function is important. Next one. A radioactive substance decays at an annual rate of 13%. Remember, this is a no calculator problem. If the initial amount of the substance is 325, so right away you know A is 325. Which of the following functions models the remaining amount of the substance in grams t years later? Well, real quick, just by knowing, right, your initial amount is 325, you know it's 325 times something to the t power. So you know C and D can be eliminated. Now, if it decreases, right, 13% after that, you know you're going to go 1 minus 13% because the rate is 13%. So 1 minus 0.13 is going to give you 0.87. Therefore, your B value is 0.87, and that would be letter A. These are problems you should get. The next one, again, this is a tough one, right? It's no calculator, and it's gridded response, so you can't use the answers to help you. It says here, Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique is estimated to grow or increase 10%. So you know your rate is 10% and it's increasing, right? So we know we're going to do 1 plus the rate, and understand that 10% would be, that's rate, 1 plus 10% is 0.1. So this would give you 1.1. The estimated value of the antique in dollars 2 years after the purchase can be represented by the expression 200A, where A is a constant. What is the value of A? What they expect you to do is to write the exponential function. F of x equals, our initial amount is 200 times our B value is now 1.1 to the t power. But what you have to know here is the 2 years. So when I do this, that would be 200 times 1.1 to the second power. Now, here's what they want you to get. That writing this out, 1.1 squared would be the same as 1.1 times 1.1. So when we look at it, 1.1 times 1.1, that is the A they are referring to. Because that would give you 200 times 1.1 times 1.1. Remember, 11 times 11 is 121. And if I move the decimal 2 places to the left, it would give you 1.21. And you would grid that in, 1.21. That would be your answer. Because 200 times 1.21 is the same as evaluating this function in exponential form. All right, example 5. Given this function, the function f is defined by the equation above. Which of the following is a graph of y equals negative f of x in the xy plane? Again, no calculator problem. So here's what I would do. I would create a table, okay? And this doesn't take much. You basically need 2, maybe 3 points. F of x equals 2 to the x plus 1. So I'm going to plug 0 in. Remember, anything to the 0 power, that would give me 2 to the 0 plus 1. Anything to the 0 power is 1. 1 plus 1 is 2. If I plug 1 in, 2 to the first power plus 1 is going to give me 2 plus 1, which is 3. Right? Then, if I plug 2 in, 2 to the second power plus 1 would 4 plus 1 is 5. So now, when we talk about the opposite of f of x, all we're going to do is we're going to use these input values, but now what we're going to do is take the opposite of our outputs. So 2, positive 2, would be negative 2. Positive 3 would be negative 3. 5 would be negative 5. So when I look at it, 0, negative 2, right? That is 0, 2. That can't work. That's 0, negative 1. That doesn't work. 0, negative 1. That doesn't work. We have 0, negative 2, 1, negative 3. Therefore, letter C is your answer. You really could get away with just doing these 2 points, or even just the first one. All right. Next one. It's a 2-part gridded response question. The stock price, this is a calculator one. The stock price of one share in a certain company is $360 today. A stock analyst believes the stock will lose 28% of its value each week for the next 3 weeks. The analyst uses the equation V equals 360 times R to the T to model the value V of the stock after T weeks. What should the value of R be? Well, since it's decreasing or going down 28%, you know you're going to do 1 minus the rate and 1 minus, let me erase this, 1 minus 28% as a decimal is 0.28 would give me 0.72. Okay, so that you would bubble in 0.72. To the nearest dollar, what does the analyst believe the value of the stock will be at the end of 3 weeks? Okay, so what we're going to do is say the value of the stock after 3 weeks would be 360 times 0.72, and now we're going to replace T, right, with 3. And when I do 360 times 0.72 to the third power, right, you get 134 point, it's going to be a decimal, 0.37, but they want it to the nearest dollar, so you're going to round this part to the nearest dollar. That 3 tells me to keep it the same, so it would round to $134.